Okay, ladies and gentlemen, thank you very much for being here, all of you. And let's have the start of our 7th meetup. We're really excited. It's like we passed a couple of 6 months. Yeah, just going on, doing cool stuff. Recently, we're studying a little bit more about Sophia and the Eternity project, so we decided to give a little bit more talk about what is going on and to show you some interesting things. But first of all, let's look at the news, what happened recently in our lovely blockchain community. And of course, we're very interested in all the forks and protocol upgrades and things that make our life easier or actually worse sometimes. But the long expected, okay, let's just, this is a summary of all news. Let's say Ethereum, long-awaited fork. It's finally coming. Let's see. Finally coming.
2 weeks.
Eternity with their planned first fork is also soon, actually today or tomorrow. We don't know.
Testnet.
Bitcoin, yeah. This will be announced in the second part. Bitcoin is giving us something new, interesting. I mean, always finding something new and interesting, evolving. The DAO and Monoplasma are offering some solutions of scalability for Ethereum with ARM Plasma, their vision. The Chinese guys jumping in with the blockchain engine and making things according to them more easy. We don't know if it's not more centralized, but how it is. And a few news from our friends from Windex. So let's start fast. Ethereum, we should expect it to be happening by the end of the month, okay? And it went exactly on this block number. And if everything is fine, yeah, we will see actually not one but 2 forks taking place at the same time. And this will be Constantinople, the long-awaited, and Petersburg, because Constantinople is going to implement the 5 proposals a day with Ethereum, and Petersburg is just going to fix the bug that made the delay, which is the re-entrance attack for those of you who missed this information. And I just skip a slide. And today or tomorrow we will have it's long planned since the release of Roma this September or autumn. Let's call it autumn.
Which one?
Of Eternity mainnet. There was a planned 3-phase of token swap, or yeah, this is how we can call it. And today there will be the first release of Minerva, but it's going to happen only on testnet. And we will observe, the developers will observe for some time how the network is behaving, and eventually, if everything is well, calculating by the time, maybe it will go live on the 6th of March. This release is bringing us some improvements of the Eternity virtual machine, Sophia language, and state channels, much awaited and very good stuff. Also, let's say the gas fees will be increased to protect from spam and attacks on the network. 1 million times. I was surprised at the number. I just decided to write 1 billion. Okay, thank you for the correction. I saw so many zeros, I said, wow, so much. And also interesting, now with this release, the miners will be able to set their minimum gas price that they will be willing to work on the network, so to mine your transactions. And maybe let's not skip this, it's important information. So the first phase ended a few days ago on the 15th of February. And this is for the people that want to swap their tokens from the ERC20 to the new tokens, or the native tokens. And eventually their tokens will be available on the network after the main net release, which is on the 6th of March. So that's it. Let's move on. Bitcoin, Blockstream, they like to make some cool stuff. I like very much what they do. So now they bring us bring it to the network to verify whether you have some funds on your in your wallet, and they're using the BIP 174 partially signed Bitcoin transaction. So cool stuff. If you want to do these checks without making transactions, you can try it. I personally like those stuff. So this is not the minimum viable product, but it's the more viable plasma chain. It's kind of, I think, experiment, but they are running now the Ethereum mainnet. This is made by dApp. It's been announced almost everywhere, so maybe most of you have seen it. What to expect, this is their vision of things. We can see that ERC20 tokens and ERC721, we will be able to transfer them faster, it will cost cheaper, but at the moment, we will not advise you to do this. I mean, as a developers we can, and there's also a faucet, we can get some test stuff, so go for it and try it, but otherwise it's unstable because it's in alpha state. There's no security audit, if I read it right, so yeah, that's how it is. And another project that's also using the same technology like Plasma, building something around it, is the Steamer. Yeah, Streamer, also sound. Streamer, they make their own vision of around Plasma and mono Plasma, because they envision this to be from one to many. It's like a broadcasting money. To do it off-chain. Actually, I had information about the previous one, but I skipped to tell you, so that's it. This is with a special purpose of off-chain scaling solution to broadcast money. So you can use, you basically avoid some problems around the network, and maybe it's a good solution. We'll see. And we're coming to the Chinese guys building a platform. It's a Baidu blockchain engine, allowing you to make more fast and easy dApps. They say programming dApps will be something like programming normal apps. They're willing to solve the problem with computation and also storage that are running. The thing is built on aepps, like super cool for marketing guys. aepp data computing technology, and they hope that this is going to help commercialize the blockchain technology, allow people to play around, make it more easy for developers. They aim to simplify commercial deployment, as I see what I wrote, and they offer also templates for deploying, not only for deploying, but templates for smart contracts, templates for they offer templates. You can go and play around with things. I just missed the last part of it, but that's almost what it is. Actually, I see this as a positive news from China. I'm not really sure how the developer community is excited about using. This is most likely going to be used like big corporations or things like this. This is not, for me, not the ultimate decentralized solution, although they mentioned that this is supposed to be a solution for this decentralized application. But overall, they say it should be easier for developers to go on and develop things, much easier, like click and you're gone. You're done. And last, we're happy to share with our friends from Wadex. They are doing something, actually not something, but what they're doing, we'd like to share. They're working currently on implementing their exchange on aeternity Sophia ML, and soon we'll see this, we'll hear from them. I think they're maybe halfway through, or maybe on the advanced already. And they also release a version of their mobile website that you can go and check. They're preparing really cool stuff for DEX. If you go and see their new web page, it's really cool. And see how many things they plan to implement in the future. So I'm excited to see what this will bring. And yeah, I think that's it for updates. Now we will pass on showing you really some real stuff. Yeah, do you want this one?
Yep.
Thank you very much.
Okay, I got my chief here, chief. So Sophia aeternity language means meta language. It's Sophia, and it's mainly developed for creating smart contracts, as I said. It's a strongly typed language. It has a restricted mutable state, unlike Solidity in Ethereum, meaning that we don't have an arbitrary mutable state, but only a limited form of state that we can define and associate with each contract. And we do this with a special keyword called state, and we are basically encapsulating there the state that we can mutate in the whole smart contract. The initial state is provided in the and set and initialized in the init function, which is something similar like in Solidity's constructor. Although there is a little difference in Solidity, for example, we have default value of everything, which is basically 0 or null or false or whatever. In Sophia we don't have this, so everything we need to set up and initialize in the init function. We have a special function that is called put, and via this function we can find the state and modify it later. So besides that, everything else is like a normal functional language. And another thing is that if you want to modify the state in some function, you need to have the stateful keyword when you are defining the keyword. We'll see it later. This is how a smart contract comparison looks like. We've shown this before, but it's something simple for beginning to show how similar it is to Solidity. We have here like defining the contract name and the state variables. We have two functions to set and get the data from the state. On the other side, we have the Sophia smart contract language, smart contract, which is, as we said, it's strongly typed, but it has also, if you have programmed before in a functional way or another functional programming language, you will find it similar. We have here something like in Python, which is like the indentation space is mandatory. Here we have the state that we can basically mutate in the future. And the init function, we are initializing it with 0. The other two functions are for setting and getting the state. So we'll see a bit more complex example in later. Sophia has lots of similar types that we can use. Here we can check it on the GitHub page and see everything, but basically we have, like in Solidity, integers, addresses, booleans. Bits is the new thing that will come with Minerva. We have strings, lists, tuples, and record, which is a key value pair similar to the structures in Solidity. Also we have maps and options. Option is a value where we can basically say we can have an optional value for something. And we have the state, which is the mutual the variable we can mutate in, and we have transactions, events, and lots of other stuff. Also, we have built-in oracles we can access and get information from. Sophia offers us built-in functions, which are pretty cool. For maps, for example, we have lots of built-in functions for lookup, finding a member in the map, deleting, calculating the size, or transforming it to a list or from list to map, which is kind of useful because in Solidity, for example, we don't have this. We have string manipulation functions, which are also pretty useful. We have the whole thing can be checked in the GitHub where the protocol is described, but this is basically the function that we can use. We have built-in functions for integers. Basically, this is the only one for now we can use. Also, we have cryptographic functions. We can calculate the hashes of something. This notation here is generic, so we can basically do cryptographic stuff inside the smart contract, which is useful again. We have interface built in for contacting oracles, registering oracles, getting questions and responses from oracles, and we can query them, providing them fee and getting the answer back, which is useful, and we'll see it working with soon, I believe, with lots of other interesting apps built on Eternity. And we have an interface for accessing the chain and making transactions like value transactions, transferring value. Also, we have some primitives that are predefined in the Sophia protocol. We can, similar as Solidity, we can access the, for example, block hash or whatever, or contract address. These are the Sophia primitives we can access for the contract, for the call, which is similar to message.sender in Solidity. For example, we now have here code origin or code caller, and this is from the transaction perspective. And we can access the chain and get the block hash or the number or the balance of some address or stuff like this. Everything can be checked here. Interesting thing about Minerva is that after today or tomorrow, when it becomes available on the testnet, we can perform some of the things I mentioned because they are not yet implemented. But later on, it will also support built-in safe arithmetical operations. For example, in Solidity, we now have libraries like SafeMath for using math operations, addition, subtraction, and whatever. We now will have them built in, and they will be safe in a sense that they will behave as corresponding operations on arbitrary state integers, for example, and we will be protected from overflows and underflows on the protocol level. It's pretty interesting. We basically will throw an error if we get an overflow or underflow. Because another thing I forgot to mention is Sophia is working with 256 bits words, 32 bytes. And we have two types of, the types I mentioned, they are basically separated from two types, boxed and unboxed types. The unboxed types are the, for example, int, address, or boolean. They are represented as a big endian 256 bits words. And the box types like list or tuples, they are represented as a 256-bit pointer to the heap where there is something called heap object in the memory, which is a continuous sequence of words describing the whole list, for example, or tuple. And yeah, that's for the descriptive part. Now we'll see a working example and we'll walk through it. First, I'm gonna show you the Solidity version of this contract because it will be similar for you, I believe. And then we'll see how it is working on Sophia. We will be, do you see it, or should I?
Can you bring up the prompt? Yeah.
Okay. It's better, I believe.
Yeah.
Okay, so the contract we'll be looking at is a simple auction contract. We'll have basically a functionality to create an auction and bid and outbid other participants, and then at the end of the auction we'll have the function to the auction owner can withdraw the highest bid, like the value from the highest bid, and other participants can be refunded and withdraw their bids. So here in Solidity we are basically defining our state variables. We have owner, start block, end block, and a boolean whether the auction is being cancelled or it's still active. We have the highest bidder variable where we'll be saving the address of the highest bidder, and we have a mapping which is pointing to from address to uint, which will be saving our bid amounts. And we have 3 events which are for logging the bid, logging the withdrawal, and the cancel event when the auction is cancelled. Here we have a constructor. I assume you're all familiar with Solidity. This is being called when we deploy our contract, and we basically are providing 2 parameters for the start block and for the end block, which will be defining our auction when it starts to be available and to which block it will be running. We have 2 requires here for a safety precaution. We need the end block to be higher than the start block, and we need the start block to be a bigger number than the current block, because we don't need to activate it from the past. We are here providing also an error message, which is if this require fails, we will be receiving this on the console. Also, we are setting the owner of the auction, and we are setting these 2 variables here. So we also have some modifiers that will help us reuse some code. We have modifier to check whether the auction is being cancelled or it's still running. This is to check if to let us through if the auction is still running. We have modifier for checking the owner and for not being an owner. We have also modifier to check whether the auction is started or whether it is ended. We have another to check whether it's cancelled, and another to check both of these. Okay, so this is the fun part here. We have a function to place the bid. I'll walk faster in the Solidity because it's not that important today. So now, as you know, we are describing here our modifiers, and our function body is here. We also want to reject payments that are less than some amount, so we need to have a value provided for the bid. We are saving this bit here in the memory, and we are calculating the whole amount of bits that are being passed from the same user. So if I bid now and bid again, my balance should be increased. Also have here the last highest bit, and we require the new bit to be higher than the last highest bit. So we need to have provided some amount that is enough to overbid the previous bit. And we are updating the balances here and emitting the lock, the event lock for this. We have a withdraw function, which is basically accessible only if the auction is ended or cancelled. We have 2 variables here, the withdrawal account and the withdrawal amount. So if the auction is cancelled, we are setting the withdrawal amount here to the amount that every participant is provided, and he can basically refund later here. He can get his funds. Otherwise, we have here in the else statement, we don't want the highest bidder to withdraw his bid, so he is unable to withdraw his money because he's the winner, and only the owner here can withdraw the amount of the highest bidder, so the winning bid can be withdrawn only by the owner of the auction. Here we have it required to not withdraw 0 ethers. And we have a function to cancel the auction and set the state to cancel true, which will be then used in these functions regardless. Okay, the fun part. So as we said, the Sophia smart contracts are Sophia is strongly typed first, and the contract has a particular way to write a smart contract because, as I said, the indentation space and the syntax is very, very important here. First, we define the contract name, and then it's similar to the Solidity version. We are defining the state variables. As I said, we don't have we only have an arbitrary state in Sophia, so we can only mutate further everything that is in the state. This is a keyword here. If we have another thing here, for example, another structure of something, let's say name string, we don't have a way to mutate this in the future. We only can mutate whatever is defined in the state. So here we want in the state to have the owner of the auction. We want to have the start and the end block. We want to have the cancelled variable, the highest bidder, similar to this, and the mapping, which is a key value pair of address to int, which will be the amount that the bidders have provided. Interesting thing is that if you see here, we are defining it similar like a JSON kind of JavaScript object, but yeah, the whole syntax and the whole syntax can be found in the GitHub of the Sophia language, and it's pretty easy when you write one or two contracts. It's kind of easy to get used to. This is the special way to define events. We are defining them as data type events, and we can then basically define our events here and provide the variable and the arguments that they are accepting, parameters. Interesting thing about events is that they support only 3 indexed arguments plus 1 which is optional, and it can only be string. So this word indexed, it's not used by the aeternity node internally, but it's used and it can be helpful for security checks and security software that is finding vulnerabilities or stuff like this, analyzing the smart contract. So it's good to have it. And yeah, these are the 2 events that we are defining, similar like in the Solidity version. We have the log the bit, we have lock withdrawer and lock the cancelled event if the auction is cancelled. This is our init function, which is like the constructor in the Solidity version. This function is okay. I don't have typo here. Okay. The function is getting two parameters, the start block and the end block, similar like here. The interesting thing is we are defining the type of the parameter after it with the semicolon and then the type, and we now have the return type here, which is the state. In other functions, if I don't know if this contract has another, but if our function needs to return an integer or something else, we just type it here. Okay, we now have the two requires again, which are similar to the Solidity version, but the interesting thing is we don't have a built-in require here in Sophia, so I've implemented this helper function, which is using the built-in abort, which is reverting the transaction if something fails. So we can create a helper function for reverting the execution if some condition is not met. We just name it require. It gets two parameters, the boolean, the condition, and the error message to be provided if something fails. So this is a helper function that makes our smart contract more similar like Solidity and easier to read. Also, I have defined, I will show them a bit later. Okay. Here we are setting the initial state, and this is mandatory, as I said in the beginning, because we don't have a default value for everything in Sophia. So we are setting the color, the owner here as the call.caller, which is basically the address that is sending the transaction. We are setting the start and the end block in the state here, from these the two that are passed to the function, and the initial cancelled state for the auction is false. The highest bidder is the zeroth address, so this is how you type an address here if you want to provide it with numbers. And the funds by the bidder, which will be our mapping, is just an empty object for the beginning. Then this is our function for placing bids to the auction. We don't have here modifiers like in Solidity, but we can define ourselves some helper functions again and use them in the beginning of a function, and basically if some of them fails, it will be reverting the transaction, so it will be similar to modifiers in Solidity. So I'll jump to them to see how I've defined them, and then, and then we'll see how the function is working. So here are the so-called modifiers. Like in the Solidity, we have again a modifier or a private function for checking if the auction is still active, which is calling here this internal helper function. We can access the state variables with state.something, and it will bring us this value here, which is initialized again here, and if it's mutated somewhere in another function, we will return the last value. Okay, this is the only not cancelled modifier private function, and we are using this helper require function again that we've created in the beginning. So we have again a private function for checking if the owner is the caller, and we are accessing this call.something, which is built in Sophia, similar like message.sender in Solidity, for example. We have here another check if it's not the owner, and if the transaction is made after the starting of the auction and before the end, and another check which is here only ended or cancelled, similar like the logic here. Okay, so now when we've defined our helper functions, we can just walk through the main ones. The function that is placing the bit will start by checking and passing through every of these functions, and if some of the conditions there are not met, it will just revert the transaction. Another check that we want to make is to see whether the provided value is more than 0 AEs, because we want to have provided value for the bit. We can define here sort of memory variable, which is living only during the execution of the function, similar like in the Solidity, which is where we can define memory variable used only in the scope of the function. Here we are getting the state dot funds by bidder, so we are accessing the this mapping here, and we are getting the amounts of AEs that somebody is provided, and we are incrementing it again with the provided value.
Can I interrupt you? How can we see that is a memory in the memory?
As I said in the beginning, we only have a mutable state, which is defined here. So whatever you are defining here, it's not saved anywhere. It's only during the execution and during the transaction. We can use it like this, but it's easier if you are if you set it to a new variable for easier readings, at least. And we are also saving the last highest bit by accessing the state here. Again, we have a require to have the new bit to be greater than the last highest bit, and this is the maybe the most different thing in comparison with the Solidity. If we want to write something on the state, we are doing it by using this built-in function put state, and then this is what we are updating in the state. It's basically updating only because we cannot append something different than this what we've defined in the beginning. So we can only mutate the things that are in the state record here. Okay, so here we are updating the bits for the caller, and we are updating the new highest bidder is the caller of this transaction. And for announcing events in the blockchain after this transaction, we are doing this with chain.event and the name of our event, with the parameters that it is requiring. So our event here is requiring an address and int, which will be basically the bidder and the amount that he has provided. So this is done here. The withdraw function is a bit more complex, but it's easily understandable. As I said, when we are modifying the state, we have this keyword here, stateful, if our function is not modifying the state but only reads, we can remove it and just public function, whatever. So the withdrawal function here, we are following the same logic, but it's a bit more, I don't know, tricky. We are setting here the withdrawal amount, similar like in the Solidity version. Let me just go here. Okay, here we have defined the memory variable, which will be holding our amount that we can withdraw later. Here we do this like this, again with let, which is a keyword for defining a new variable in the memory, and we need to provide the type of the variable here. So the type is integer, but the value is returned by this switch statement here. So instead of nested if, because nested if is not a good practice in Sophia in the first place, and then it's kind of messy to make nested ifs without with this syntax, because we don't have brackets here, and it's harder to read, and then more mistakes happen and stuff like this, and the switch is basically very fast to execute. So we are reading the state and check whether it's cancelled or not, and we are providing the switch cases here. So we only have two cases for this, whether the state cancelled is true or false. And with this arrow function, which is syntax for provided from Sophia, we are basically telling what to do next. So if the state is cancelled, we are just returning this here to this variable. So this is it's left associative. So when we return value basically by just saying or typing the name of the variable that we want to return. Or for example, if we want to return 1, we just type 1 here. So this is what we return to this variable withdrawal amount in this case. In the other case, when the action is not cancelled or it's finished normally, we want to have the highest bidder to not be able to withdraw his bid again. So we have the require here, and we are checking whether the caller is the highest bidder. So if he is trying to withdraw his bid, he will be returned this error message here and won't be able to get his money back. And again, we have this short check whether the caller is the owner of the auction, because he should be able to get the value from the winning bid. We are returning this by getting the value of the highest bid, and if some other participant is trying to access the withdrawal function, he basically is returned the value that he's provided for the bidding contest. So everything after this switch statement is returned to this variable here, withdrawal amount, and we are passing it to this helper function again that we've created ourselves. This is something like a convention. We can have these ticks here, like withdraw prime, or read it whatever you like, but it's sort of convention. This is the function that I've defined down here to proceed with the payment. It's basically receiving an address to send the value to and the amount to be sent. It's defined as private stateful function again because it's modifying the state. We have the beneficiary address here, so this is the caller here, and the withdrawal amount that is calculated via this switch statement here. So we have a require again here to not have 0 as an amount, and we are basically saying here we are withdrawing and minimizing the amount from the mapping where we are saving the amounts for every bidder. With chain.spend we make a transaction, which is chain is the interface we have to access the like transfer in Solidity or send or whatever. So chain.spend, it gets 2 parameters, the address to whom should be sent the amount, and we are firing this event, logging the withdrawal that happened with the beneficiary address and the amount. So it's similar like Solidity if you look at it, and it's looking more like Python or Haskell or OCaml or whatever, more like functional style. The only difference here, I believe, is this put state and whatever. Everything else is like in the normal functional programming language. We have the function to cancel the auction here, which is using these 3 kind of modifiers, and then again modifying the state to set the canceled to true and logging the event for the cancellation. Am I missing something? I believe that's it. We can try to compile this contract. I haven't prepared unit test or something like interactive demo, but maybe I'll do and share the resources then. So this is something like Remix in Ethereum. The Eternity team are working as we speak to improve the user interface and the functionalities of this, but it's kind of useful as it is. So we are basically pasting here our contract code, and we can try to compile it here. It's accessing the testnet here, as we can see, with a predefined account, and we can, if you want, you can basically change the settings to your local node or to the mainnet if you want to deploy it later with your private and public keys. So after the compilation, we receive the bytecode of the contract, and we can deploy it here with the arguments that our init function is expecting. So our function is expecting 2 arguments, which are the start and the end block, as an integer. So we can basically say something like this: the start block to be 45,000 and the end block 50,000, and we can try to deploy it. We can provide here the gas amount and fees and everything else. Another thing I forgot to mention is if we have some error here, if our contract is not being, if we have some syntax error or something like this, we have here useful information box with error message, and which we can follow then and fix our contract. We are waiting for someone to mine our contract, which usually happens faster. But yeah, it's still testnet, so let me just try again. Okay, we won't wait it. Okay, so we can try, I don't know, modifying something to see when the compilation fails. We see here an error message providing us where exactly our error is with useful information, what we've missed or something like this. So about the IDEs and local development, there are lots of tools being built right now. One of them is Forge, which is something similar like Truffle, which is providing us local development first like structure of our project with predefined with local node that it's setting up, and with predefined and filled some addresses and private keys and wallets that we can use for testing purposes. Another thing is up until yesterday we didn't have syntax highlighter, so I've created one and it's accessible here. If you are coding with Visual Studio Code, you can search it here, like search Sophia. And yeah, here this is the first one. You can install it and have a nice looking code. Yeah, I can show you how you can basically create a example project with Forge if you want. Maybe it will be useful after with the recording. You can install Forge with npm install Forge for Java. Yeah, it's written for JE globally. I have it installed, so I won't install it again. Maybe I can bring up the font. Yeah. And then we can create our create a new directory, and then we just say forge init. Oops, forge. Yeah, it's initializing it's basically creating us a simple directory of the project where we have it's like this. I'll show you in a bit. We have contracts folder, deployment scripts, and tests folder where we can write tests that are pretty similar to what we have in Solidity and Ethereum development. It's JavaScript based, so
Is it Mocha?
yeah, it's Mocha. It's basically the same, so it's easy to switch from Solidity to Sophia development. Also, here we have the Docker configurations, because there is still no simulation of the chain like we have in Solidity. We have local simulation without running a node. We can simulate transactions and stuff like this. We still don't have this in Eternity, but as a workaround for now, we can use Forge, which is firing up a Docker with a local node, which we can then access to whatever we want. So we need to fire Docker, and yeah, here is what we have when we initialize an empty contract. We have here an example contract with just an empty state and a function that is returning whatever you pass to it. So this is the basic structure of a initial contract in Sophia. Yeah. Another function that Forge will be supporting is deployment to the mainnet. For now, you can run a local node, compile, and run tests like in Truffle and Solidity. So whatever it's written here, when you run forge test, it executes here and checks your tests. Let me just check if I have something with tests to show. Not sure. Nope. I believe here I have. Okay, I have here some tests. So you're, I believe, familiar with Mocha. We have all coded and written tests for Solidity. It's similar. We here can predefine our addresses that we can use later for like convenience. We have here different addresses for the owner, not owner, and whatever we want to have predefined for the test. This here that I'm showing is a basic address book contract, which is okay. It's defining basically people and putting them in a mapping to an address. So this is a structure. Again, this is a record of person which has a first and last name and age, and it's saved in the state. So we are defining here basically like in the object-oriented languages, we can define structures and then use them here and whatever. This is a simple contract, a lot simpler than the other one. The init function only has an empty mapping of people, and we have 2 or 3, okay, 4 functions for adding person with the address, first name, last name, and whatever else, age, which is returning a boolean. So here it is the last row of the function is the return value. We are again saving this to the state at this key here on the mapping, and we have 3 getters to get the first name, the last name, and the age, which are basically the same, with the only difference that we are just returning here the first name, here the last name. I have a typo. Okay, I don't have a typo. In the if I'm checking the 3 things, and the age here. The interesting thing is here this lookup. It's basically again a helper function that is looking up in the map and searching for whatever you've provided here, and it's returning an option if we don't have anything written on this particular key in the mapping. It will be returning the value that is provided here. Otherwise, it will return the found value. If it is something written on this particular address, it will return its value. It's being used here with the past 3 arguments: the address, the state, people, which is the mapping here we are passing, that we are looking up on, and the default value that will be returned if there's nothing found there. So we'll be returning a person with first and last name false and age 0. Again, that's a simple contract. I believe our Docker is running, so we can try run the test. Okay, we just need to run forge node to initialize basically to fire our local node in the Docker. So we need to wait a bit and then try the contract. maybe I can show you here in GitHub we can see the Sophia language definition and features and short examples and explanations how everything works. We can have here here it is the table with the types, and everything is pretty good. It's pretty good defined and described. The documentation is pretty good. So yeah, we can basically get ourselves familiar here. It's a lot easier when you read it first and then try to create some smart contract on Sophia. I think our Docker is fired. We have here several wallets with which are pre-funded with some virtual, not real Eternity tokens for the testing purposes. And now we can run forge test, which will be running our tests from the test folder. It's a bit slower than testing in Solidity, for example, now, because, as I said, there is basically virtualization of the chain there, and here we are running it directly on the local node that we just fired. So yeah, it's similar like in Solidity. We have here basic Mocha, which I believe every one of us has tried. And yeah, that was from me. I will share, it's already in GitHub, but I'll share the resources for this meetup again later tonight. And yeah, if you have any questions, I can try answer them. I'm not that familiar with Sophia, but
I have a really question. Do you normally write Sophia as Solidity, or you write Solidity as, Sophia as Solidity?
well, the only thing here as Solidity is defining helper functions for the require and for the sort of modifiers.
So you're doing this possibility. So it's easy.
You can define yourself whatever helper functions you want. So if you're familiar with Solidity, you can predefine some list of helper functions and basically write in similar like in Solidity. Like it will be more functional, yeah, but it will be.
What is the reason for writing these helpers functions instead of having the modifiers? Is there a particular?
There is no modifier in Sophia.
Yeah, why?
There is no, because they haven't implemented this kind of feature.
They haven't implemented it yet, or they're not planning?
I don't know if they are planning it, but it's a nice question, and you can bring it up. They have
Create an issue.
public dev hangouts I believe every Wednesday. Actually, yeah, today was this week's hangout. The next week or in the forum you can ask and raise this issue or question or proposal.
Cool. Because the language looks quite intuitive, right?
Yeah.
Only this is counterintuitive.
Yeah, but
to some point.
yeah, it's, I don't know. It's,
How do they deal with those things without those helper functions? Are there any other examples, contracts that you've encountered that they use something else, but not those type of helper functions?
you can write everything in the function itself, but this is again like in Solidity saving. You're basically making reusable code where you can use again. That is the function of modifiers in the first place.